Good morning, everybody. My name is Kurra Kiran, and my branch is Mechanical Engineering. Today, my subject is Design of Machine and Elements, and my topic is Friction and Wear in Robot Arm Joints. Here, we can observe that Introduction to Friction and Wear in Robot Arm Joints. Friction and wear are critical factor affecting the performance and longevity of robot arms. Understanding this phenomena helps in designing more reliable and efficient robotic system. And this presentation explore the causes, efforts, and mitigation strategies for friction and wear in robotic joints. And basic concept of friction. Friction is a resistive force that opposes the relative motion between two containing surface. There are different type of frictions, including static, kinetic, and rolling friction. These are different types of friction actually, and managing friction is essential for smooth operation and energy efficiency in robot joints. Now, we can observe here types of wear in robot joints. Wear refers to the gradual removal or deformation of material from contact surface. And common wear types include adhesive and abrasive surface, fatigals, and wear. And wear impact the accuracy, speed, and lifespan of robotic joint. Now, we can observe here causes of friction and wear in robot joints. Robot joint. Material properties, roughness, and lubrications qualities influence frictions and wear. Operating conditions like load, speed, and environment factors also play a significant role in this wear in robot joints. And improper maintenance and design flaw can accelerate deteriorations of joint components. And here we can see that the effects of friction and wear on robot performance. Increased friction leads to higher energy consumption and potential overheating. Wear can cause joint misalignment, backlash, and the reduce positional accuracy. Both phenomena can result in increased maintenance cost and unexpected downtimes. Material used in a robot joint to uh, mitigate wear. Selecting material with high hardness and low friction coefficients can reduce wear. And common material including ceramic and composition and specially treated metals, which they are useful for the mitigate wearing. And coatings such as diamond like carbon DLC are often applied to enhance surface durability. Now, lubrications techniques for a robot joint. Proper lubrications minimize direct contact and reduce the friction and wear. Type of lubrications including grease, oil, and solid lubricant. Depending on applications, we can use these types of lubrications. Especially, we can use the lubrications like grease and oil. Regular lubrications maintenance is crucial for ensuring long-term joint performance. Basically, used for the robot joints. Now, design strategies to reduce friction and wear. Incorporations, precision and manufacturing and surface finishing. Improper contact conditions also one of the type of reducing the friction and wear. And using compression and the alternative joint mechanism can reduce stress and wear. This also one of the what we call one of the method to reduce the friction and wear. At the same time, at the last is implementing real-time monitoring systems helps predict and prevent joint failure. This is also one of the friction and we are reducing. Now here we can see that future trends and technology. Advance in biometric materials aim to create more wear resistive and low friction surface. And another one that is the integration of a smart sensor enabled to predictive maintenance and operation optimization. In a, emerging lubrications techniques and surface treatment continues to improve joint durability means absorption of the material and energy to be released for the future trends. And conclusions and summary. Managing friction and wear is vital for the reliability of robotic arm joint. Here, vital means nothing but it's important in the futures, and it is mainly causes and important for the robotic arm joint. And material selection, proper lubrications, and innovation designs are key mitigation strategies. These are the key vital rule and the key things for the this experiment, and they are that is mainly selection of material and proper lubrication. And ongoing research and technology advancement promise to enhance robotic joint performance significantly. Once you can recall what we are learned here, here the topic is friction and wear in robot arm joint. And one more thing, introduction to friction and wear in robot arm joints. Nothing but it is the main factor and the performance of the longevity in robot arms, and it is more reliable at the same time. And basic concept of friction means nothing but it is a motion between two contacting surface, and there is different type of frictions. Basically, we can use static and dynamic and kinetic rolling. This we can use essential for this experiment. And robot joints are mainly wear types are abrasive and surface and the corrosion wear. These are the some of the type. And friction are mainly it is content of the material selection and surface roughness and lubrications. This way while we are dealing with this experiment, we know this some of better for the quality influence and wearing the frictions like factor also play a significant role in this friction experiment. And material used in the robot joint is mainly we can use the reduced wear because of it have the low friction coefficients which we can use in this high hardness and low friction. At the same time, it have the material like ceramic and compositions we are using in this experiment for the better coating and durability of surface. And lubrications techniques for the robot joints is mainly the techniques are there is different type of lubricants which we know, and they are mainly grease, oil, and solid lubricant depending on the application. Based on the application, we can use the lubrications for this direct contact and reduce the friction and wear. And the design strategies to reduce what are the design we need to mainly we can base it on the alternative joint mechanism which we can reduce the stress and the wear. With the help of that only we can implement the real-time monitoring system. And future trends and technologies basically we can say that it is low friction surface which is better for the future. At the same time, it have the creative more wear resistive, and it has the lubrications techniques such as treatment continued and improving the durability. Here that is the conclusion is nothing but we can say that robotic arm system is basically it is vital because of in long time, and we can durability also it have so much. And that through that we can say it have the important role in the magnet managing the friction with the two surface. And other thing that is material selection is mainly we can select material selection like ceramic and composition. That are some of materials to select. Proper lubrication means nothing but there are different type of lubrication based on the application. We can use the lubrications like what we call it as like grease and oil and solid lubricant. At the same time, and the innovative designs are key mitigation strategy. Nowadays, we can observing that there is so much innovation. Based on the innovation, we can say that is a little bit of great and significance of the mainly managing the friction of the robotic arm joint. At the last point, we can observe that ongoing research and technology advancement promise to enhance robotic joint performance significantly. By searching this experiment, we can advancement is nothing but to promise to enhance the robotic joint performance significantly with the help of the innovation. Because with the innovation, we can say there is was some of the reliability and durability is comparatively great. And this is the last to say thank you. Once we can see the what are the what we are not discuss that these are the slides we just we saw. These are the importance of this. And the last time thank you.